So I think, well, today's 11/2. We'll start with that. I think we're going to call these age change problems. I'll put that in quotes because, it's not very official. It just seems like when we do them, you'll know what I mean. So they're age change word problems. If you really are good at embracing the whole variable declaration stage of the four-step process, you're not going to have much trouble, even when they get really hard tomorrow, because today's is due tomorrow. So we're going to have a lot of work time and like 8 problems that we got to get done. Tomorrow's get harder, but if you embrace what I'm going to try to teach you today, this idea of past, present, and future, then I think you'll just always be fine. If you rebel against the first step, then, they're nigh impossible. Okay. Cool. So as always, I'm going to type these up and just know, by the way, that we are on the home stretch. Age change problems signify pretty much like the end of the road here. So this is it. Got to remember which one I want to do first. This one. Ooh. Sally is 9 years older than Hank. In 12 years, their ages will total 101. How old are they now? Bless you. So there are 3 time frames that we talk about in human existence. Well, in time in general, they are called the past and the present and the future. And generally, these problems, most of them, almost all of them, are going to consist of 2 of those phases. This problem consists of the present, you would agree, and the future. The next example is not going to deal with those. So we have to bear in mind as we go through the variable declaration, just understand the English and say, what are my time frames? That's going to be important. So the first thing generally that we want to do is declare variables for what we know to be true. Like we know right now at this point that Sally is 9 years older than Hank. So who do we want to be our X? For sure. Yeah. So we're going to let X, and again, you can start using contextually specific variables if you want. There's not a lot of people doing this yet, but if you wanted to let H, you could let H equal Hank's age. We'll just stick with the X. Everyone seems to be comfortable with that. So we're going to let X equal Hank's age. And it's important that you specify now. You don't have to put it in all capitals like I did. But the thing about this is here in a moment, we're going to define Hank again, but it's not going to be the same Hank. It's going to be future Hank, right? So we're going to have 2 packs or 2 sets of variable declarations. You'll do this on every single problem now for the next like at least 2 days in my class. So 1 down, 3 to go. So we also can define Sally right now. What is Sally's age? Yeah, so X plus 9 is Sally's age now. And again, I'm going to use capital letters and I might eventually stop, but just to make the point, that's really important that you specify that. I'm going to draw a little bit of a line now, and now I'm going to go on to the other phase of time, which sometimes will be the past, sometimes it'll be the future. Again, in this case, it's the future. So we now want to talk about what we know about Hank in the future. So I'm going to switch colors, and I'll say, like, let blank equal Hank's age in 12 years. Excuse me. Yes, in 12 years. That's right. So you're good enough at this. Like if this was our very first word problem, it might scare you a little bit, but man, this is like your 94th rodeo. So how old will Hank be in 12 years? That is correct. Hank will be X plus 12. So again, my color change here is to signify that we're not talking about the same people now. We're talking about them. There's like Hank and Sally, and then there's future Hank and future Sally. They're like, ooh. And so now we also need to say let blank equal Sally's age. Yes, it would be. So we're going to take whatever Sally's age is now, and again, we're just future jumping here. So we're going to say in 12 years, if she's already X plus 9, in 12 years, she's going to be X plus 9 plus 12, aka X plus 21. Got it? So we have to now consider which variables we want to use to write our equation. And that's going to, the choices are, do we want the red ones or the green ones? Sure. You got a bleeder? Uh-oh. So since the problem tells us that in 12 years, we're given the total of their ages, would you agree that we want to use the green variables? Okay. So what does it mean if their age is total 101? What does that mean? When they're added together, they will equal 101. So we're going to take future Hank. We know him as X plus 12. And we're going to add to that future Sally, who's X plus 21, and make the claim that in the future, the sum of those two futuristic ages will be 101. Does that make sense? Nice. And as always, once steps 1 and 2 are done, I feel like, ugh, light work, man. If you're very faithful about step 1, especially, then there's nothing that could possibly get in our way. The algebra is ho-hum. How many x's do we get? 2x plus what? Plus 33. And then what do we do? Subtract 33 on both sides, giving us what? 68. And then we divide by 2, giving us what? 34. So it's important, as always, at the end of step 3, like a broken record, to take a step back, assess the situation, and ask yourself, am I interested in X, or do I want to modify it to answer other questions? Let's see. The question was, how old are they now? What is X? I mean, don't say 34. What is it? So I just answered one of the questions. Because the problem's asking me about right now, X is my right now. So I can make my little yellow answer box now and say, Hank is 34, comma, and Sally is, and I don't think you have to put years old. I mean, if you want to, but I mean, we kind of get that idea, right? And Sally is 43, 34 plus 9. Yep, 43. Put a box around that sucker. And that is your first, other than like the Grok problem from assignment 16, that's kind of like our first age change problem. So that's how it works. You define one phase of time, you define variables for the other phase of time, and then you decide which phase you need to write your equation, and then you answer the question. Easy peasy? All right, let's do one more. Yeah, easy peasy, squeeze some lemons. Is that how that goes? Flip is 13 years younger than Susie. 9 years. Flip is not 131 years younger than Susie. Thank you. Flip is 13 years younger than Susie. I don't even know how to blame that on a fat finger. I don't think you can. Yeah, fat brain. Flip is 13 years younger than Susie. 9 years ago, comma, Susie was twice as old as Flip was then. How old are they now? So I wanted to make sure I didn't want to do any more than 2 examples today because I want to give you work time, but I wanted to make sure that the second example consisted of different time periods. So what would we say this time? What are we talking about? The past and the present, right? So our X is probably going to be from the present, and then we're going to build the green variables, the past ones, off of what we decide for the present. You're not going to encounter, I say, much difficulty today. This assignment, I looked through it. If you can handle these 2 examples, you're going to be just fine. You should be 3-4 minutes per problem, which just about right with the end of class. Let's do this. So we're going to say let X equal what? No. Yes. X is going to equal Susie's age now, because the relative statement of Flip being younger than Susie, that's happening right now. That is a present tense verb. So Susie currently and Flip are 13 years apart. So what are we going to say for equals Flip's age now? Hmm? Because Flip is 13 younger, so he's whatever Susie is minus 13. And then I'll draw a line, and we're going to go back in time now. So we're going into the past. So we're going into the past by 9 years. So I'm going to switch colors, and I'm going to say let blank equal Susie's age 9 years ago. It would be. If she's currently X, we decided that, then 9 years ago she was what she is now minus 9. Like your age right now is X. 5 years ago, you were X minus 5. And what are we going to say for Flip's age 9 years ago? So I'm going to write this off to the side just in case anyone's wondering, and then I'm going to erase it here in a second. But Flip is currently X minus 13. And if we go back in time, we got to take away 9. Hence the decision to just do what Zane said, X minus 22. Good. And that's it. That's kind of the multi-pack, the value pack of variable declaration. And now we're going to write an equation based off of this fact right here. I'll underline it in blue for you. 9 years ago, so we know we're using the green variables, Susie was twice as old as Flip was then. That whole sentence reeks of everything's in the past tense. Everything's in the past tense. Use the green variables, only the green variables. And so how are we going to write that? So Susie's age 9 years ago, if we take twice that, then we'll get equal to how old Flip was 9 years ago, which was X minus 22. Does that seem right? I'm not sure I like where this equation is headed. I feel like we're going to get a negative answer. Does that seem possible to you? Yeah. What, say again? Well, no, it's not what it is. I wrote this well, that's what I'm saying is something has gone amiss here. Something has gone awry. So Flip is currently 13 years younger than Susie. 9 years ago. I know, and that's not possible, is it? So Susie, yeah, I made the mistake that I'm always telling you kids not to make. And so we have to, this is why I use words. And I remember now why I use words. We want Susie to be, so I'm going to write this in words. We want Susie in the past to equal twice as old as Flip. So we had the 2 on the wrong side. So remember, we want Susie's. Yeah, someone said that over there. Good job, Kyla. So we want Susie's x minus 9 to equal twice Flip's x minus 22. Yeah. So you can, I mean, I didn't mess up on purpose. Honestly, in my career, I have made mistakes on purpose just to draw attention to mistakes. That time it was just shows you how easy it can happen. I was not on purpose. So Susie is twice Flip. Using words helps. Okay, better. This makes more sense now. So we're going to distribute. So step 1 is done. Step 2, after some clumsiness, is done. Step 3, let's just grind through the work. So we have x minus 9 equals what? And then we're going to pull the x over to here. And then we're going to add the 44 over to here. And we're going to get 35. If that happens to you where you get a negative, then you can kind of learn from what we just went through and say, well, God, I must have done something dumb. Because like ages aren't going to come out to be negative, right? Same with like weights, things like that. So what did we just find? So Susie right now is 35. So we can make a little sentence down here and say Susie is 35, comma, and Flip is, how old is Flip? Whatever that is, minus 9, which is good. Wait, isn't it? He's minus 30. It's minus 13. What are you trying to brainwash me over there, you Jedi? It's okay. So it's 22. And that, my friends, is enough to get you through assignment 17 without any issues. You guys good? All right.